All right, guys, we're going to be looking at density today. And in this problem, we're going to be having to make some calculations that involve actually calculating the volume of a three-dimensional object. All right, so let's go through it. The density of an American white oak tree is 752 kilograms per cubic meter. If the trunk of an American white oak tree has a circumference of 4.5 meters and the height of the trunk is 8 meters, what is the approximate number of kilograms of the trunk? Now, as soon as we hear that word or read that word density, let's go ahead and write down the formula for density so we know where we're at. Density equals mass divided by volume. And then what I'm going to do is I'm going to come over and draw a tree trunk. So let's assume that this tree trunk is cylindrical. Okay, and one of the things that we know about this cylinder or this tree trunk is that it's got a height of 8 meters and that it has a circumference or distance around the tree at 4.5 meters, and that is the circumference. That's going to be very important to pay attention to. Let's go back and identify some things that we know so we know what we need to solve for in order to continue this problem. So it does tell us in this problem that the white oak tree is 752 kilograms per cubic meter. Well, if it tells us that we have kilograms per cubic meter, that's telling us our mass over our volume. That's telling us that our density is equal to 752 kilograms per cubic meter. Okay, so we know our density. And then what it says is it is asking for what is the approximate number of kilograms. So it's asking for our mass. Okay, so it's saying, what is our mass? Well, one thing we don't know is we also don't know the volume. So we also are going to have to say, well, what can we calculate? Well, we need the volume. Well, what is that? It gives us information about the volume. We're talking about a cylinder, okay, and it gives us the height of a cylinder and it gives us the circumference of a cylinder. So because of that, we should be able to find the volume of a cylinder. And so what we have is volume of a cylinder, if you remember, is pi times the radius squared times the height. And in this problem, the volume of a cylinder is, it gives us that right away. It says that the height of it is 8, but it doesn't give us the radius. It gives us the circumference. So one thing that we are going to pay attention to is the circumference is 2 times pi times r, 2 pi r. Okay, and it says, well, the circumference is 4.5, which we know we can set equal to 2 pi r, which we can make an easy calculation for the radius by just dividing by 2 and pi. Okay, so let's go ahead and do that. R will come out, we divide by 2 pi, and let's go to MattDoesMath, and let's just type it in, 4.5 divided by 2. Now what that gives us is 0.716. How about we use 0.72? So that says that the radius is equal to 0.72. All right, so now let's go ahead and we can find the volume of this cylinder or the volume of this trunk now. We can say the volume of the trunk is going to be pi times 0.72 squared times 8. And let's go ahead and type this in. So pi 0.72 squared times 8 is going to bring us to roughly 13.028, or let's just go ahead and say that the volume of this cylinder or the volume of this trunk is going to be 13.03. We'll just go ahead and round it up. And we're talking about meters, so this will be meters cubed. So now let's go ahead and take this, and we found out that the volume of this trunk is 13.03 meters cubed. Okay, now we can actually find the mass of this trunk, which is what we wanted to do, is find the exact mass of this trunk. So let's go ahead and do that. Okay, I've got the density, which is 752. And I've got the volume, which is 13.03. So let's go ahead and type everything into our formula. 752 equals to the mass over our volume, which is 13.03. And we want to find the mass. So what do? We just multiply 13.03 13.03, and we multiply across. This will cancel, the mass will come out. And let's go ahead and type that into DeSMAth. So 13.03. 13.03 times our density of 752, and that is going to give us 9,798. Okay, so let's write that down, 9,798.56, and that is going to be our mass in. All right, I hope that helps you out with this problem. I know these problems get long when we talk about density, but they're good for problem solving. Hope you all have a great day. Hope this helps you out. We'll talk to you later.